Welcome back to the discussion and thank you for always joining us. K.c.s.e 2003 paper 1 question number 16, a question on integration. And the question we have reads: the velocity v meters per second of a particle in motion is given by v is equals to 3t squared minus t plus 4, where t is time in seconds. Calculate the distance traveled by the particle between t is equals to 1 second and t is equals to 5 seconds. We have been given velocity function and we need displacement, and for us to get displacement we are going to integrate the velocity function, which is 3t squared minus t plus 4, and the displacement in this case will be equal to, when we are integrating, we add 1 to the power. Remember, we have power 2. You add 1, it becomes 3. Then you divide by the total new power. This one is going to give us 3t squared. We add 1, you divide by 3, minus t, this is raised to power 1, plus 1, you divide by 2, plus you introduce t in 4. Then you add c, which is a constant of integration. For this case, our displacement is going to be equal to t power 3 minus half t squared plus 4t, and since we are getting the distance, we do not need the value of c in this case because it is going to cancel. So you insert the limits, that is t is equals to 5 and t is equals to 1. So we are going to substitute the maximum value of x, which is 5, then substitute the minimum value of x, which is 1, then subtract the two values. The maximum value of t is 5, this one is cubed, minus half times t, which is 5 squared, plus 4 times t, which is 5, then minus the minimum value of t is 1, we are going to cube this, minus half times t, which is 1 squared, plus 4 times t, which is 1. 5 power 3 will give us 125, minus 5 squared is 25 times half will give us 12.5, then plus 20, minus, we are going to have 1 minus 0.5 plus 4. Remember, 125 minus 125 plus 20 minus 12.5 will give us 132.5, minus 1 minus 0.5 will give us 0.5 plus 4, giving us 4.5, and 132.5 minus 4.5, you get 128 meters, since this is distance or simply displacement. Thank you for watching. Remember to subscribe. We are moving to the next question. A question which was done in the year 2004 in paper 2, question number 22, and the question we have reads: a particle moves in a straight line. It passes through a point O at t is equals to 0 with a velocity of 5 meters per second. The acceleration a in meters per second squared of the particle at the time t seconds after passing through point O is given by a is equal to 6t plus 4. Part A, we are told to express the velocity v of the particle at the time t seconds in terms of t, 3 marks. Remember, given the acceleration function and you need velocity, you are going to integrate the acceleration function, which is 6t plus 4, and we're integrating acceleration in respect to time, and therefore the velocity is going to be 6t. This is raised to power 1, we add 1, then we divide by the total new power, which is 2, plus 4, we introduce a t when integrating, then we add a constant of integration, and this one is going to be equal to 2 goes to 6 3 times, such that we have 3 squared plus, that is 3t squared plus 4t plus c, and we know at t is equals to 0, the velocity of the particle has been given as 5, and therefore using this general equation, which is 3 times t, t is 0 squared plus 4 times t, which is 0 plus c. This one will be able to give us a velocity of 5, and in this case our c is generally going to be 5, since 3 times 0 squared is 0 plus 4 times 0 gives us 0. Hence, the specific function for the velocity will be 3t squared plus 4t plus 5. That is part A of this particular question. In part B, we are told to find the distance covered by the particle, that is B Roman 1. B Roman 1, we are supposed to find the velocity of the particle at t is equals to 3 seconds. Therefore, at t is equals to 3 seconds, then the velocity is going to be equal to, we take the velocity function and replace the value of t, which is 3 squared plus 4 times t, which is 3 plus 5, and this one is going to give us 3 squared is 9 times 3, which is 27, plus 4 times 3 will give us 12 plus 5, and this one is going to give us an answer equivalent to 44 meters per second, since that is velocity. Then in Roman 2, we have been told to find the distance covered by the particle between t is equals to 2 and t is equals to 4. Remember, to get the displacement, we are going to integrate the velocity function, which is 3t squared plus 4t plus 5. As usual, when we are integrating, we integrate each term independently. We have 3t squared, we are going to add 1, then we divide by the total new power, plus 4t, this is raised to the power of 1, we add 1, then we divide by the total new power, which is 2, then 5, we introduce a t, and at this point we are simply going to have 3 and 3 will cancel, giving us 3t cubed. 2 goes to 4 2 times, that is plus 2t squared plus 5t. We do not need to introduce c because this is distance or displacement. Then the limits we have been given are between t is equals to 4 and also 2. At this point now we substitute the maximum value of t and the minimum value of t, then subtract the 2. Therefore we are going to have 4 cubed plus 2 times t, the value of t is 4 but it is squared, plus 5 times t, which is 4, minus the value of t, which is minimum, is 2 cubed, plus 2 times t, which is 2 squared, plus 5 times t, which is 2. In this case, we are going to have the first bracket. Using a calculator, we are going to get 116 minus the second bracket is going to give us 26, and the final answer is going to be 116 minus 26, giving us 90 meters as the answer to this particular question. We are moving to the next question, a question that was done in K.c.s.e. 2005, paper 1, question number 16. And the question we have reads, the acceleration a in meters per second of a particle is given by a is equals to 25 minus 9t squared, where t is time in seconds after the particle passes through a fixed point O. If the particle passes O with a velocity of t over 4 meters per second, find an expression for the velocity. In this case, to find the velocity, we are going to integrate the acceleration function, which is 25 minus 9t squared. To integrate, we are going to take 25 and introduce t, then minus, we are going to take 9t squared, we add 1 to the power divided by 3, and this one is going to give us 3t cubed. Then we add c, which is a constant of integration. At this point, we know when t is equals to 0, the velocity is 4, and therefore v is going to be equal to, remember v is already 4, which is going to be 25 times t, which is 0 minus 3 into 0 cubed, plus c, meaning the value of c is going to be 4, and therefore the specific function for the velocity will be 25t minus 3t cubed plus c, which is 4. And by so doing, we have done the first part of this question. Then we move to the second part, which is b. B, they want us to calculate the velocity of the particle when t is equals to 2 seconds. And in this case, we can say at t is equals to 2 seconds, then the velocity is going to be 25 times t, which is 2, minus 3 times t, which is 2, then cubed plus 4. This one is going to be 50, minus 2 power 3 is 8 times 3 is 24, plus 4. And this one is going to be 50 plus 4, which is 54, minus 24, which is going to give us 30 meters per second as the answer to this particular question. Thank you for watching and welcome to our discussions. And in case you are watching this channel for the first time, please take a second or two, you click the subscribe button so that anytime we publish a video like this, you will automatically be given a notification. For the questions, online classes, or any other inquiry, feel free to contact us through 0701 686 283. Thank you and welcome.